Today, we're diving into something that powers so many of the apps and websites we use every day, yet it often works completely behind the scenes: JWT, or JSON Web Token. What is it? Why is it so popular? And how does it keep you logged in while protecting your data? By the end of this video, you'll know exactly how JWT works, when to use it, and even some cool tricks to avoid common pitfalls. So grab a coffee, sit back, and let's get started. First, let's explain how JWT works using a visual representation. Then we'll create an application in Python that uses JWT. In the first step, the user visits the login page of a website. This is where the authentication process begins. The user interacts with the website, ready to provide their credentials. In the second step, the user enters their username and password to authenticate themselves. These credentials are sent to the server to confirm the user's identity. In the third step, if the credentials are correct, the server creates a JSON Web Token. This token is like a digital pass that proves the user has successfully logged in. In the fourth step, the server sends the JWT back to the browser, packaged securely inside a cookie. The browser stores this cookie, which will be used in future interactions. In the fifth step, the user tries to access a restricted page on the website. This is a page that only lonely logged-in users with a valid JWT are allowed to view. In the sixth step, the browser sends a request to the server for the restricted page. Along with the request, it automatically includes the cookie that contains the JWT. In the seventh step, the backend service checks the JWT inside the cookie. It verifies whether the token is valid and ensures that it hasn't been tampered with. In the eighth and final step, if everything checks out, the server processes the request and sends the necessary data back to the browser. The user can now view the protected page without any issues. This step-by-step process ensures that only authenticated users with valid tokens can access secure areas of the website. Now, let's implement the same example using Python. This code implements a Flask application that uses JWT, JSON Web Tokens, for user authentication and authorization. At the start, necessary libraries like Flask and Flask JWT Extended are imported for web development and JWT handling. The time delta module is used to configure the expiration times of tokens. The JWT secret key is set to super secret key, which is used to securely sign and verify tokens. The application defines an access token to expire after 15 minutes and a refresh token to expire after 7 days. Access tokens are short-lived tokens used to authenticate users for accessing protected resources. Refresh tokens, on the other hand, are long-lived tokens used to request a new access token without requiring the user to log in again. A JWT manager object is initialized to enable JWT functionality, and a token block list is created to track revoked tokens. Additionally, a user's dictionary is set up to represent a simple user database where usernames are mapped to their passwords. The /login route handles user login. When a user sends their username and password via POST request, the app verifies the credentials against the user's dictionary. If valid, an access token and a refresh token are generated using create access token and create refresh token. The access token is what the user includes in their requests to access protected endpoints. Because access tokens are short-lived, they provide better security. The refresh token, being longer-lived, is designed to issue new access tokens when the original one expires, reducing the need for the user to log in repeatedly. These tokens are sent back to the client in the response. If the credentials are invalid, the app returns an error message with a 401 status code. The /logout route allows users to log out by revoking their tokens. The @JWT required decorator ensures that only authenticated users can access this route. During the logout process, the unique identifier, JTI, of the user's token is added to the token block list, marking it as revoked. The unset JW cookies function is also called to clear the JWT cookies from the user's browser. A response is sent back confirming the successful logout. The /protected route demonstrates how protected endpoints work. It uses the @JWT required decorator to ensure that only requests with a valid access token can access the endpoint. If the token is valid, the app retrieves the current user's identity using getJWTIdentity and returns a personalized message. The check if token in block list function is a callback that checks whether a token has been revoked. This function is used to enforce token revocation by checking if the token's unique identifier, JTI, is present in the token block list. If it is, the token is considered invalid, blocking access to protected resources. The /route is a simple public endpoint that greets users with a welcome message indicating that the app is running and available. Finally, the application is set to run in debug mode when executed directly, allowing developers to test it locally. This example demonstrates how to securely implement JWT-based authentication in a Python application, including token creation, verification, and revocation, while leveraging the benefits of both access and refresh tokens. Now let's activate the server. I'm running the main.py file. The server is now active. To demonstrate how the application works, I'll use POSTMAN. POSTMAN allows you to make requests like get, post, put, and delete to a server. The /route contains public data, meaning we can access it without authentication. When I make a request to the /route, the server successfully returns the response. Let's try to make a request to the /protected route. Since we're not authenticated yet, the response failed. Now let's try logging in. We had created a fake database using Python. First, I'll try logging in with an incorrect password. As expected, the login failed. Now I'll try logging in with the correct password. The login is successful, and the server sends back an access token and a refresh token. I'll now try to access the protected data using the access token. Without a token, I still cannot access the protected data. I'll select the bearer token option in Postman and use the token to access the protected data. With the token, I can now access the protected data. If the token had been invalid, I wouldn't have been able to access the protected data. Next, I'll try logging out using the token. Again, I'll select the bearer token option in Postman. The logout process was successful. Now I'll try to access the protected data again using the token. This time, due to an authorization error, I couldn't access the protected data. So, what have we just walked through? Let's break it down. First, the user visits the login page, ready to provide their credentials. Then they enter their username and password, which are sent to the server for authentication. If everything checks out, the server creates a JSON Web Token, JWT, which is like a digital pass confirming the user's identity. This JWT is sent back to the browser and securely stored in a cookie. Next, when the user tries to access a restricted page, the browser sends a request along with the JWT in the cookie. The server then checks the token and, if it's valid, grants access to the requested page. And that's how secure authentication works. If you liked this video, make sure to subscribe to the channel and join us.